This is a representation of us, and this is a representation of our computers. Now we are trying to make them understand our language. Why? What's so special about our language? Because our language has got three major things. One is word meaning, the second one is grammar, and the third one is sentiment or emotion. When I'm talking about word meaning, I am not exactly talking about the whole sentence meaning or something. I'm just talking about individual word meaning. So as we already know that if we interchange the word positions in a sentence, it will not make I mean it might not make sense anymore, even though the individual word meanings are not changed. And this is because our great grammar that we have in our languages. And we also know that when we are writing a sentence, a certain emotion or sentiment we have in our mind, and when a reader is reading that text, they can get an understanding of the sentiment. And that's why thriller books often becomes the bestseller, because it creates thrills in our brain. So, in some cases, sentiments can be a bit ambiguous as well, because we have a sentiment that is called sarcasm right now. So, when we are talking about sarcasm, it is very hard to express that feeling in a sentence. Suppose I am saying that the boy has got um, good looks. So, it can be told in a sarcastic way and also in a very normal way. By the way, those who don't know what is a sarcasm, sarcasm is something that is meant negatively but with a positive sentence. So that is very tough to express in a sentence, because the sentence is actually positive, but at the way you are saying it, it is making it negative. So computers will not get the idea by just looking at the sentence, because even us can't do it. So these three things we need to convey to our computer buddies. Let's start with word meaning. So when we are talking about word meaning, we don't need to bother about the whole sentence meaning, or the whole the whole textual meaning of the thing, but the summary meaning kind of thing. We don't need to bother about that. We just need to bother about individual word meanings. So we know what the word means in our language, but we need to somehow transfer that into computer language. So to do that, we use two specific techniques: tokenization and embeddings. There are multiple others as well, like stopword removal and all those text normalization, all those things. But I am considering those as a part of tokenization as well. So this is the way to transfer convey the word meanings to the computer from our language. And in case of grammar and sentiment or emotion, for these two cases, uh, we are not going to use tokenization or embedding. We can just use some ML or DL model, because see, these are not exactly hard coded kind of thing, or maybe these are more complicated compared to word meanings, because these have got internal rules. Like for sentiment, we can from reading this sentence based on some specific words, we can identify the sentiment. For grammar also, we need to look at some specific detail of the language, some rules we need to learn. So here we'll be needing a model that will basically learn the internal rules. And when I'm saying tokenization and embeddings to use to convey the word meanings to the computers, what I am meaning by that exactly. So I want to get into a bit deeper into this thing. So there are two stages: tokenization and embedding. So for tokenization, uh, we are converting a huge textual data, a large textual data, into a dictionary. So you can say that this is a dictionary. Now, why are we making this dictionary? Because this dictionary will be helpful to the computer. Because see, when we are making this dictionary, we usually call this dictionary as a vocabulary, and we build this dictionary, we build this vocabulary from a large textual data, which is called corpus. So from this large textual data, we basically take the most important words and create a vocabulary so that the computers can refer them in future. So in future, when this computer guy is looking at a text which it doesn't know, so it will immediately refer to this vocabulary, and it will try to find the words in it, or maybe parts of words in it. And as he has got some words in the vocabulary, he will now use some techniques, which is called embeddings. So there are some particular embedding algorithms which will basically tell him that which words are more similar and which words are not very similar, with the mathematical representation. So as you can see that it will get a uh, it will be converted, the words will be converted into a matrix, into a numerical matrix. So in this matrix, looking at this matrix, the computer can understand very clearly what is happening inside, but we will not be able to, definitely, because we are not computers. But are we? Are we not computer? I mean, our brain is a computer only. Anyway, let's go ahead. So once we have got the matrix, we can just use the matrix to feed into a model next to learn the grammar and sentiments. So based on the and once the model is learned, this model can be anything. This model can be an ML model, this model can be a DL model, I mean deep learning model. And this model will be learning a function. This model is basically a function, so it will apply that function to the matrix. So this function will actually capture the grammatical and sentimental patterns from the language, and it will encode in numbers, right? And once the function is applied, it will generate some number. Based on that, the computer will get an idea key what is happening inside the data, and it will make sense out of it. Now once we have learned and once we have trained the model, we need to evaluate. So there are a bunch of evaluation methods and evaluation metrics for these processes. But this is the whole pipeline for an entire NLP project. You need to first convert the convert the linguistics to numbers using tokenization and embedding methods. And after that, you can train a model, and then you need to evaluate how your model is doing. So that's pretty much it, and I wanted to tell that only. And we will be looking into different tokenization methods and embedding methods, and also different NLP modeling algorithms. So some state of the art tokenization methods that we will be looking at is looking at our word tokenization. So word tokenization is actually quite old, but we will have a quick recall of that anyway. But subword tokenization, this is a boss, you see. Now this is the real deal, subword tokenization, because this is what big players are using it. Bird, Bird, Transformers, LLM, ChatGPT, you know that, right? So those guys are using this subword tokenization in their pre-processing so that the model performs better, and it is performing better, right? And for embeddings, we have bunch of different things like uh, we have what to wake, we have glove. Other things also we have, but these are the two big chunks, so we will go through it. And also for modeling, there are lots of models, like every ML model, basically a lot of, I mean, most of the ML models can be applied here based on the problem statement. If it is a regression problem, we can use regression model. Classification problem, we can use classification models. But in, I mean, specifically as language data is a sequential data, so we can use a lot of sequential modeling like RNN, LSTM, GRU, and then comes the transformers, uh, then bird, and then GPT and other large language models. Now the point is, I have not mentioned some of the models yet. Like probabilistic models are very popular in uh, in NLP, but those I have not mentioned here. But we will be going through those as well, like hidden Markov model and also some other probabilistic approaches. We'll be going through that. It will be really exciting series. Stay tuned, guys. Thank you for watching. See you soon. Bye.